Welcome everyone for Codegeneration for Implementation Guides with Gino and Canessa. I guess I just heard. No, it's Jens and Gino are doing Codegeneration for Implementation Guides here, and it's more of a free format as well. So feel free to ask questions during, get your just go on, I guess.
This is birds of a feather. We want it to be informal.
Exactly.
So
and
please yell at us.
If you want to speak, please just raise your hand so I can give you the mic so we can actually record this.
Yes.
And I guess that's
Sounds good.
Yeah.
And if you can go alternating parts of the room to make Martin run around.
Yeah,
No.
that's also fun. And it's all on camera, so we can laugh about it later.
Yes.
Okay.
Perfect. Thank you. So yes, I'm Gino Canessa. I'm joined here with Jens. And I never pronounce it correctly. No, I know it's spelled, but Villedsen. Yeah. There we go, Villedsen. And we want to talk about code generation for implementation guides. We'll jump there. A little bit of an agenda. We're not going to stick to it too closely, but I don't know. I always put them in slide decks. So I also have the obligatory about me slide because I'm a software engineer at Microsoft, and they pay for me to be here, and I think that that's worth noting. Very appreciative of that. I work in research in a group of health futures, working on standards interop and all the fun stuff and contact information there. So I don't know if you want to introduce yourself first.
Yeah, sure. So I'm Jens Villersen. I'm from Denmark, and I'm the CTO at a company called Trifork in the digital health division. I've been around the block, maybe not as long as Gino, but at least in the FHIR sphere. Probably FHIR longer, around 10 years. Yeah, I guess that's the gist of me.
Fantastic. All right, so here's my prompt. We're chasing the horizon there. This is a perennial ask. It is unfortunately complicated to actually make all of these things. We were discussing some of this earlier. And so we're going to talk about a couple of different approaches in a couple of different languages, some of the challenges, some of the requests, all these types of things. Everything here is very much a work in progress. That is to say that there's parts that work very well. There's parts, I think you have parts in production already? Maybe? Ish? Yeah? No? Okay. Getting close to having parts in production, but yes, so we'll talk all that more. I do wish I could report more progress. I had a similar session last year, but cross versions has taken significantly more time than I'd hoped, and then feedback helps. All the people who work on these things, we're all oversubscribed, but when people prod us, we tend to make time to do something, because we always feel guilty when we don't. So really, we're talking about how to make using implementation guides easier, right? Because now developers are trying to do whatever they need to do. I use, just because they're easy, some of the US core patient examples. Like there's US core birth sex. And it's an extension on patient and blah, 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 blah. When you want to use it in practice, then you have to go in your SDK and model of choice and say, I'm looking at my patient resource, and then I need to find the extensions, and then I need to grab the URL from the implementation guides. Let me go look that up, and let me put that in here. And after I have 10 of these, I might split them out into another file and have a list of constants, and then, I copy-pasted something wrong, and I'm looking for the wrong extension, and I didn't notice because I just thought it wasn't present, and you get into all these kinds of weird errors and stuff like that. So a lot of this is to try and hopefully lower the bar for implementations to make them easier. I'm going to clarify here, we're in two competing worlds, and I have some more fun. Yes, well, it's a friendly competition. It's the buy each other drinks type. And so I work in Codegeneration in C#, and that builds C# stuff, TypeScript stuff, Ruby stuff now, but not profiles yet. And then Jens is representing Graham's work and Jens's work together, working on the Java side, which is based all in Happy and everything else. And we have kind of two different approaches that are based in language capabilities, which ties into all of our fun issues later. I didn't actually talk about anything on the slide. All this stuff is open source. It's in an experimental branch, low-level code, read all the versions of FHIR specs, normalize it, output code, do all the fun stuff. Yeah, but it's all there, so people can read, contribute, debug, whatever. When we're talking about these things, we're going to treat IGs as packages, implementation guides. It's not actually true. IGs are not strictly packages, but we can pretend, and in this case, that pretend is what we care about. It's just an NPM package that has all of your definitional artifacts, all of your conformance artifacts. So it has structure definitions, value sets. I think those are really all the ones we care about generally in this case. And it's a distribution format. There is a whole host of things about the dependency trees on how you resolve all of these things. I am going to pretend that doesn't exist for this session, and I think we have other sessions that talk about all of the canonical resolution. I think Nikolai has one later this week as well. Personally, I started with the C# side, working on Firely stuff. That's what everyone uses in C#, so it's a great target. And we already do a lot of code gen for the underpinnings of that, so that was a great place to start. Working depth first, so I want to finish one language before porting that process into another language, because trying to build new features in multiple languages at the same time usually makes my head hurt. And then I have these concepts of levels. And if you notice, most of my slides say, this is open source, please contribute, for all the developers in the room. Level 1, I just did extension URLs. So the same thing we were talking about earlier. Even if you're just using their models as they are, it's still helpful to just have all of the URLs from the package. Add all the comments, put type information, put complex information for sub-extensions, and so you can see there's kind of the example. So we take in a package and we generate these handy files instead of making you copy and paste them from the web yourself. And they have, extension URL abatement with allergy intolerance abatement. But it has the summary, and it has the remarks, and all of your type information. So that's one of the other pieces, being able to say what you can put in extension, because if you don't have the hinting from there, then you have to remember what's allowed when you looked it up on the web page, which is pretty annoying. As you get more complex, then we started adding, here are all the sub-extensions, so that when you say, yes, I have the artifact assessment content, that URL is a complex URL instead of just a value that has all of these sub-extensions, and then those get their own with all of their type information so that you can walk up and down the tree, at least in your code editor, and nowadays probably just ask AI. I haven't tried playing with that with this kind of info. It should do pretty well. The next level we tackled was value set stuff. So do expansions that need to, all that kind of things. Filter out all the impossible sets. We don't want to expand UCOM into your code. We don't want to expand MIME types into your code. That would be funny, but only once. Same. Yeah, SNOMED. Here's SNOMED. It's in a CS file. So do all this stuff, make codes, codable concepts, accessors, all that kind of stuff. So same type of thing. What is this one? The value set of allergy intolerant substance exposure risk. And so same thing, we start building things with the URLs, and we say, hey, you want a coding of the known reaction risk? Well, here is the function that generates one and gives it back to you. So now when you want to put this in your element or extension, you can just ask for all of these things. Then we said, you know what, you also have lists of codings and you want to extract ones. So you say, in this case, the substance exposure risk is a coding, and it might have 10 different codings from different systems that I don't care about. So I want to pass in my list of existing codings that are on the element and just return me the ones that are actual ones from this value set. So that way you can say, here's a list of 15 different codings in different systems and local codes and everything else, and give me just ones that are here so that you can test, easy for validation if they exist or not. Next level, extension accessors. This is where we start getting the really painful things. And this is also where we start diverging. And I won't steal Jens's thunder here, but in C#, we're very fortunate that the language model lets us build extension functions into already published classes. So we can take things like the FHIR SDK, and we can add essentially virtual functions, and I'll jump back and forth a little bit because they're there. And so we use this this keyword, and so when you get an allergy intolerance, you can just put on your instance of an allergy intolerance object, when you hit the period to access a function, you have this get extension value of extension URL abatement, so you can just say abatement get. And that's it. So then you get this nice virtual function for getting and setting, and we can add all these things. But to jump back, this is where we start talking about the unfortunately complicated things. We have to understand the target language class model, right? In Java, that functionality doesn't exist. So we have to pick a completely different style of doing all these things. When we talk about TypeScript, again, it's a completely different set again, because now you want to use JavaScript style finders and things like that. You have to change, how you do your indexing, how you do all of these kinds of things, what kind of types are underneath. You need to figure out things like named references, so like bundle.link and then bundle.link.link, things like that, and figuring out how to get all those types reconciled. You have to make sure you're tracking the reserved keywords in those languages, because people pick the same words to mean things in the FHIR spec, and then you have a reserved keyword and no one can compile anything. Yes, that one's a fun one. Jens was having a lot of fun with that a few months ago now, I guess, at this point. And then understanding the inheritance of the inheritance structure that you're layering on top of. So for instance, you might have an extension that's on resource in the patient context, and in the language, you have to figure out how those classes are related so that you can put things in the right places and everything else. So it starts getting really fiddly. Then it gets even worse when you start talking about primitives, like in FHIR SDK. We have a data type, which is a wrapper around primitive types when you have a choice type, and then you have to discriminate within there to get the actual types and all these kinds of things. Happy FHIR has the same thing, fortunately also called data type, which I thought was fun. And then TypeScript, we use interface unions. We can keep going down languages, but everyone does it differently, and so not as much of this code is reusable as we would like, which is very unfortunate. Complex extensions, same thing, just start doing nested, so then we can start adding more things so that you can get like the substance out of a risk record, and so you get the allergy intolerance, substance exposure, blah, 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 blah. Same things, but you can see the code starts inflating and inflating and inflating. Then profiles, which is another layer on top of that, which is what people actually want. So we spent all this time talking about things that you probably don't care that much about to get to the one thing you want, which is things like slice accessors, so that you can start talking about, we add lots of documentation, so you have like the must supports and things like that, the profile URLs and versions. And in the C# implementation, we fall off a cliff because this is still the work in progress. To say, I want to talk about a questionnaire object, but I want it to be an SDC-based questionnaire, and I want to use the assemble get, and then it does all these things. This is generated code, so it's there. It's just not tested enough. I'm not comfortable enough saying it's done yet. So if people want to play and you're using C#, please do. And then we have a bunch more things like that. But then, yes, like I was saying, you can see here, I did have an example for a patient, and you see you type patient.uscore, and this is in VS Code to use the language server there, and you can see then you automatically get all these nice extension getters and setters and all these different things that are the things that you have on the US core patient, but it's just on the standard stock patient object. Same thing with questionnaires and all that stuff. So it's fun. And then I've been rambling. Yeah. So then we'll talk about some comparisons with Java.
Yeah, I can ramble a little as well. So basically, an old fart like me started out doing web services back in the days. And so you're used to the concept of VSDLs and later on open APIs. And that's what a reasonable expectation is from a developer perspective. Can I just, you have all this great documentation, can I just not generate something that just fits my case? Well, sure you can, it's just hard. And the problem essentially lies in the fact that FHIR comes with a predefined data model. So everything you do from there is adaptions, extensions, and constraints. And that in there lies the problem. For instance, when you come from I think the first time I actually started fiddling around with this is now 10 years ago. At the second version of DevDays. And, well, I kind of succeeded with the rudimentary generation of profiles. And in the Java world, and it's really about, so if you have a tool that can generate something, it's actually not just enough just to take the language into consideration. You also need to take the tech stack that you're setting on top of into consideration, because it may have opinions. And if you come from the Java world and you're doing something, let's say backend-ish, you most likely use the FHIR stack. And God bless Smile for making that available to all of our Java devs. It makes our lives easier. But it also relies on mainly using, or it's most easy used if you rely on using the core FHIR generated classes. It simply just lowers your technical debt if you can stay within that. Which means that if you need to generate classes based on profiles, it's way easiest if you can sort of baseline your stuff off the already predefined FHIR classes, or technically it's HL7 classes, but same thing. Right now, so the stuff that I've done is I basically just piggyback on the great work of Grahame, and I just made it more easily accessible using a Maven plugin. It's still in very early days, but it has been so in several years. So, but it works. But it comes with the caveat that it does not base the generated classes. If you throw in an implementation guide at it, it will not extend the FHIR classes. Meaning that whatever you generate, it won't just be plug and play into your FHIR stack. At least not if you're on the back end. And then there's also the perspective about, do you really want to have something that tailor-defined inside your backend if you would like to sell that backend both in the US and the European Union and whatnot in North Africa? Because they will all have different profiles. So you can actually question, what is the value? Because you would like to have as generic as possible backend as you can get it. So there is sort of an underlying problem, or you can move the complexity all the way, all the different places where you like it, but it needs to go somewhere. And the question is actually where you would like to have it. You can put it in your backend, but it wouldn't be very specialized. So for the Java stack, I usually say, and it took me several years to come to this sort of epiphany, that I would actually like to not use this on my backend setup, because my backend setup needs to be as flexible as possible. I should be able to deploy it for different business constraints, and I would like to have the same code running all places. So that was a takeaway that took me quite a while to get at. Now, most of my colleagues actually work in Kotlin. We still use the FHIR stack. And in Java, we are not as blessed as in the .NET world, where there are extension functions. It simply doesn't exist, at least not natively. But it exists in the Kotlin world. And one of my colleagues actually last week, because we're doing some BFFs work on top of the FHIR stack. So we are sort of decoupled from our general purpose platform. So we are fortunate enough to actually start looking into this generation thing again, but now in Kotlin. And in Kotlin, we have the opportunity to use the annotations, the Kotlin annotation that's called deprecated. I haven't looked, it's still very much early days, but the problem with generating code on top of the FHIR classes, for instance, for your identifiers, let's say you slice that or you change the cardinality. Well, you can generate sort of helper methods on top of that, or static helper methods, whatever. But you still expose the underlying properties of your identifier, if that's the case. And you really don't want that, because basically you bypass all the work you just had. But with Kotlin and the Kotlin compiler, you can add that, or you can mark that as deprecated, and then you start getting compiler errors. So that will actually shield you, or shield your developers from accessing the base properties, and thereby nudge them over to use what you actually generated. But it's still very early days, but I'd say that Kotlin really has some perspective here. That's really interesting. Yeah. So, what's next?
So, I think part of it, before we jump more, to highlight one of the differences we were talking about. In Java, the mechanism, and Graham was going to be here, but he never made it on the official list as a speaker for the session, so he's speaking in another session at the same time. And so he had to disambiguate between the two and said, the other one, he's the only speaker, so an empty room versus having the two of us here. In Java, though, what the models end up building is a separate object class that then it's just a single liner, right, to move back and forth? Yeah. So it's a one-liner, but you have, in the case, just because I'm using the US core things, which I shouldn't be using when I'm here, we'll say IPS. We'll use IPS patient instead. Much better. Context aware. And so if you say you have an IPS patient, in the Java world, you say, I want to move this from a standard patient into an IPS patient. And then when you want to serialize again, you move it back from an IPS patient to a patient. And so that's what we were talking about, that there's pain somewhere. So if you want to be able to use those nice accessor functions, you have the extra step. Now, it's not actually like serializing the whole thing and then remapping it out. It's doing property mappings and things like that. But there's an extra step there. But in C#, we get the fun of saying, instead, you would have IPS patient, and you just add that there. We don't then block the underlying accessors, which we can have arguments on, or plus or minus. That it's very use case dependent. And so that's the other hard thing here. But it's nice things like in this case, if you're implementing in C# an operation, because you're extending your server and you want to add an operation, and inside your operation context, you have a very discriminated set because you're adding the operation from an implementation guide. So if you're implementing IPA and you want to use the IPS models because you're implementing the IPA operation, you can access those this way. And same thing, if you were doing that in your backend, you might say, you know what? For this long, complicated operation, I would rather pay the penalty of moving my object into the IPS patient and back again because I don't want to be doing all of my indexing after. So, yeah, fun stuff. And again, please do shout out at any time. I'm going to mostly get through the slides unless someone stops me. And so please do feel free.
I have a question.
Yes, thank you.
How do you deal with repeating elements that are then constrained to non-repeating elements when you are using the same class?
So the same accessor, if you use the accessors, it can tell you. And so that is this type of stuff. And so it's small code, I'm sorry, but essentially when we generate the accessors, we then go through, if we have additional constraints, and validate them in the accessor function. So you could still go in the underlying model and do whatever you want.
Right.
that's fine. But if you try to set via these, and I don't know if I have a setter here somewhere. I don't think I have an example in the slides that does that. Yeah. So, but that just generates the additional code to say, hey, we're constrained down to having a single value, even though it's an array, and you tried to add 2.
Yeah.
You can't. Same thing. I added a bunch of nullability things. This one is an older example, so it doesn't have it. But for being able to clear things, set it to null so that you remove it. And same thing, if you have a mandatory property, I think it throws an exception telling you, hey, you're really not supposed to null this. Right. So things like that.
So the setter handles it?
Yes, the setter handles that. Yep. And, the code gets very long, so I use these annoyingly short things. But it's generated code, so whatever. You're not supposed to look at it. It's fine. Oh, yeah, please.
Yeah, maybe a question on exact the same code part with the getters and the setters.
Yes.
Is there an opportunity to isolate those in good primitives which are reusable, where you can have all the heavy lifting
Yes.
in a reusable primitive, and you just need to pass this isn't the type I expect, and this is the extension URL, for example?
So in C#, and again, I always like to say, it's software. We can do whatever we want. It's just a matter of time and effort. And so in this case, when we actually generate these things, all of these, you can see I do a lot of we'll call them virtual function calls. They're not really, but whatever. To me, that's how I mentally map them. And so when you run the generator, it outputs, along with the extension stuff, a base set of things like that are the helper functions that it uses underneath all these to shorten this code as much as possible. And so, and then I reuse the functions like you can see here. I keep reusing the types that we generated and things like that to try and make all of those things as clean as possible. So there are some things like that, and there's some things that I've considered putting back as a PR into the core FHIR libraries to make some of these steps easier so that we don't have to include them in our code, because if they're useful here, they're probably useful outside of here. But that ties into, well, where is it? Oh, yes. So, no, there you go, this one. FHIR Net SDK 6 is coming soon and is a significant breaking change of everything, essentially, because it's all the things that we've been putting off for years. And I say we very loosely in that term because I have had very little input in the 6 stuff this round. So I guess I had a lot of input on a lot of the breaking changes that were deferred, but yes. But there's a whole lot of changes that are happening in the underpinnings, which means we have the opportunity to redo a lot of these things. And so in that case, some of those pieces, a lot of the accessors in general have changed and all of those types of things. And so when we're redoing it, that's another spot where we're going to do a lot of that. Oh, could you? There.
I'm just imagining how I would use these generators, and I was wondering what your target audience is. Is it an implementation guide developer or publisher, or is it an application developer that gets an implementation guide from somewhere, and then I generate the code and he generates the same code, and or does it even make a difference to think of these as different audiences or users?
Yeah, and that's one of the questions that I have open. That we want feedback. How do we want to distribute these things? It's a little bit heavy. In C#, we have this concept of source code generators that we can run. This whole process gets painful because, as we were saying before, you have to understand the entire type model of everything underneath. So even though you say, I just want to load my IPS implementation guide, we have to go and load core and terminology and everything else, bring all those things in, load them, make sure they're downloaded in the cache, read them, do all of our fixes that we do because the definitions are a lot of times wrong, do all that kind of stuff, normalize everything, put all that code, and then we can finally get to the part where we touch anything that you actually asked for. So when we run these in source generators, it's not that it doesn't work, but if you're not on a high-end machine, it's pretty clunky. I'm leaning towards something like a .NET tool for the .NET for all this kind of stuff so that people can just run it. But I've also been tempted by saying a website, and especially we can syndicate from the package registry. And then you can just say, anytime a package is published, we'll generate the updated package for you. And in the case of like C#, create a NuGet package or something like that. In the case of Java, put it in the Maven registry. In the case of TypeScript and JavaScript, put it in NPM. There are some challenges there, in particular, version of package and version of code. So it's the classic double versioning that you say you have, IPS 1.0.0, and I'm using Codegeneration version 2.3. So what are my actual versions, and when do I increment them? And I've been playing with some of the semver dashes and things like that to see if there's something that could make sense, but I've not resolved it yet. But if anyone has ideas, happy to. I don't know if you have thoughts on that one.
Yeah. Yeah, it's painful. It really is. Just because you have the generated classes doesn't mean you are on point. I mean, there are all the nasty or great, depending on how it's used, FHIR path expressions as well that you need to take into account. There may be checksum validations on some fields that will not be part of the generated code. There may be complies with or imposes. I don't know if you even handle that.
I detect it, but the generator doesn't deal with it yet.
Right. And then there's also the part about so versions, and then there's actually versions on top of that, because does the IG author has the correct understanding of semantical versioning? And usually don't. So, and it's not because they're doing a bad job, they're just not aware. And that just becomes, I mean, it's just a snowball coming down the mountain, right? Because we as developers have assumptions about how semantic versioning works. Now, the problem is if someone does not understand that concept, obviously, but just, I just remove these values and change these cardinalities, patch version. It's fine. But it isn't as soon as you get down to a compiler, it's not fine. It'll puke at you. So there's something about that. Maybe we should just not call it semantic versioning. Then maybe we should just realize it and say it's not going to be semantic, it's going to be romantic. Yeah. And that's just how it is. Yes. Else we will be putting out a lie, basically.
Yes. The unfortunate truth, though, is that most of the registries require us to use semver, like NuGet and NPM and all these things, that if you try to do it with anything other than semver, you're in a world of hurt. And so that's why it's an interesting conundrum. Because
suffix of romantic.
I like it. Well, you should trademark that. Romantic. A new IG. Yeah. And so we're getting to the end here. Looking ahead on my side, well, I do want to call out ahead. Graham is ahead right now. We always, every time we talk about this, we, like I said, friendly competition on who's ahead. So I had enjoyed my time ahead for over a year, and now he's ahead again. So in fairness, yeah, I want to finish the profile support in FHIR. Something we haven't talked about much, logical models. Yeah, so that's something else people are starting to ask more and more about as people start using them more, especially we've been talking a lot with like open air stuff, and a lot of the archetypes get ported over as logical models. And then do we want to be able to do code-generated extensions on the logical model on top of the underlying object model? Probably, like that's what I would want to do. But then you have type differences that not just understanding the type system underneath, but mapping in line the type differences that you need to talk about something like a DV-coded text that's on top of a codable concept, and how do you actually do that in the accessors and setters. Again, I assume most people in this room are interested in that kind of stuff. For me, that's really fun types of problems, and that's probably why you're all here too. So Yeah, lots more stuff, but I don't like just yelling at the void. So please, whatever other questions, we still have 5-10 minutes. So
Yeah, you were talking about like the FHIR path validation, but
Yes.
what do you think like the role of a code generation step should be? Is it like type safe accessing of the data, validation, or both?
So there's two parts when we talk about things like FHIR path when we're talking about a profile. One of them is when we describe, I don't know if I have a good one here, I'd have to go look for one. But internally, the specification uses FHIR path when you describe things like slicing. And so when you actually want to generate these things, we have to evaluate the FHIR path expressions against the internal object model to understand where that extension actually gets applied or where that slice gets applied and things like that. And so that's one level that we always have to consider is we have to run that in order to generate properly, which is a lot of fun in and of itself. The other part is then you start saying, like Martin's question about, I have this additional constraint in my profile saying I can only have one value in the array. And you might express that in FHIR path saying that there's there. But then you start putting a lot of constraints that you start saying like the whatever dot class implies that your status is in this subset instead of the standard subset. I'm not touching those right now in this profile level generation. I know they're there and I do that for other code generation that I have to do. But it is pretty painful to try and figure out how to then transpose that into object model things at runtime. It's not impossible. Again, we're doing software. We can do a lot of things, but it's pretty painful. I don't know if you have other thoughts on.
No, not. I mean, it's not addressed either, and I have some. I'm painfully aware that I've authored FHIR path expressions that will be hard to put into auto-generated profiles. Probably never happen, but that's really that. I mean, the conditional behavioral part about if this then that, and it's just hard, and that's so. I'm really Jekyll and Mr. Hyde in regards to profile generation. Whether it's, I mean, I can wake up in the morning and think I really should spend some more time on this, and then in the evening I said, fuck it, it doesn't add enough value. So it's really hard, and it's really dependent on what your case is actually. That's my conclusion so far, and I'll probably have another conclusion this evening.
Perfect. Yeah. So yes, and I go the same thing. That's why like one of my favorite use cases is actually implementing operations because I like having them there. But yeah.
Yeah. Hi. I have two questions connected to terminology and these class generation. You mentioned. That you also generated classes for the value sets, and there you would more or less explicitly generate each code as an entry in an enumeration. I think this is what I saw, but that would mean basically if the value set on the server, for example, would change if you, for example, get rid of a deprecated Snowman code or whatever. The class generator the serialization wouldn't work anymore, right?
Well, we'll put a caveat there. Did you want to continue first? Or?
No.
Oh, yeah. So this is part of that bigger discussion we were talking about canonical resolution and versioning and all these different things. In my camp, I will say, I'm not the only perspective, but I'll represent my perspective first. It shouldn't matter. And it shouldn't matter because the implementation guide is a published artifact. And at the time of publication, that value set has an explicit meaning. And if everything is versioned properly, it will always have that meaning. And that, to me, is very important, especially when you start talking about things in a regulatory context, because we can't be changing the codes that are in a value set and telling you you're regulatory required And then what do we do about conformance testing?
But I think in a distributed environment where you have a lot of client applications, this would mean that you need to update all of them if
Yes.
the backend gets
Yes, you
updated.
do. But that's true either way. Because if you're saying you're doing a workflow, for instance, and you're depending on a certain SNOMED code, if they change the code, you have to update your system. And hopefully there's a new version of the implementation guide that is published as well, because if not, what are you doing anyway? So that's the thing, is I'm not a big fan of changing things like that at runtime because, again, in most of these scenarios, you have contractual obligations, business agreements between parties and all these things. You can't just go and change a code. Your implementation, you have to go and discuss it with all of them and decide on when you're doing it and all these other things. And so to me, I'm personally less concerned about it because, yeah, you can't have a new version of your software, you know. And again, if you needed that kind of thing because you know it's something that is changing, don't use them. Like, yeah, if you know that you need to resolve that at runtime, this would be inappropriate to use and, okay.
Okay.
Yeah.
Thank you.
I don't know if you have different thoughts or.
It's really an interesting thing, right? Because about FHIR, because it's intended to be extensible, and of course, removing a code is not about being extensible. But you could encounter extensions on resources that you did not expect. I don't know if it's even legal to add modify extensions on resources that certainly, but it could happen. In the perfect world, of course, but I don't know where you live on the other side of the pond, but over here it's the real world. But yeah, it poses problems tying your code too strictly to something that is intentionally made to be dynamic. So you got pick your poison.
And I think that's one of the key things is all of these things are trade-offs. And so if you want more explicit and easy to use accessor functions, you're trading flexibility, right? Because if you want all the flexibility, you use the base extension things. And that's part of the reason why when I was talking about those levels, sometimes you just want to be able to see the extension URLs and that's all you need because you need everything to be dynamic. Perfect. We still want to help you, with that at least. A lot of times, especially when you get into the very complicated, in the US, one of the examples I use is all the burden reduction and insurance and all these things. Those implementation guides are heavy. And some of those extensions and profiles are really complicated. And I can't imagine writing code that's going through and looking up extensions and then using full URLs for other extensions inside those extensions, and you grab a value, and that value has an extension, and trying to do all those things is very painful. And so in some use cases it makes sense, in others it doesn't. As Jens said, pick your poison.
There was another question.
So first, thanks a lot for the presentation to the both of you. I had one first very simple question, which is if I'm a developer, would I have the same developer experience using the different code generation, the different languages, right? Like, should I expect the same features through, let's say, C# or through Kotlin or through Java?
No. The short answer is no. The longer answer is two parts. Like, I hope to get level 1 published on any language, because just outputting, a file in that language that I support already that has a bunch of constants in it, that's not all that hard. Level 2 isn't that hard to start talking about, like, the value sets and generating codings and codable concepts and codes and things like that. It's not that hard, so we could probably do that in most languages pretty easy. Your actual usability also depends, as we were talking about, on your FHIR SDK layer, on your whole tech stack, on everything else, what's possible in the language. We can get kind of functional-ish parity. We will never have actual parity because the languages just support different things. And, we're adding in one of the C# versions, because it was supposed to be in C# 13, but it got bumped, is adding not just extension methods, but extension properties directly. we're going to use those once they're in. But it got bumped because it is an insanely complicated thing to actually do. And so, you know, as languages add those types of things, we like to support them because that's what's idiomatic in that language. And that's why everything gets named differently, like it's all different. And so we need communities in each of those languages to work with us to decide.
Yeah, and on top of that, I mean, you could have don't expect the same flavor or experience from framework to framework. Some languages may have extra steps on top. It may be that you would like, you're a really fan of Lombok or something like that, that will then remove something but generate something else. So it will simply just be different. Also, if it grows, then potentially you could have 3 different flavors of just Java-generated classes, depending on what framework you rely on underneath.
Well,
And I think we're at time.
The
Yeah.
break started. There was
Yes.
one question, if
Yes, I'm happy to do
No
it
one
here, or I'm
minds,
happy to do it
but-
after.
whatever.
Yeah.
Yeah, just one more question and then break for everyone.
It's also just following up on what you just said. Would you ever consider generating code for different versions of a language? Because I would guess I would write the code differently for like Java 7 versus 21 or something. Or 8
Yeah,
versus 21.
yeah. So it's open source. Yeah. So I mean, if the contributions comes in, why not? But there's only so much time, free time, that is.
We just need an extra 30, 40 hours a day, and we're set. So, yes, so thank you. I don't know if you wrap. Oh,
go ahead.
perfect. Thank you, everyone. Great discussion. Appreciate it. Feel free to follow up. We're on Zulip. We're on Huva. We're on LinkedIn. We're on whatever. So, thank you.